Hey y'all, this is Miss Welch. I'm going to do a quick whiteboard video over nerve impulse or the action potential. So this is a drawing of a neuron and you can see the structure is already laid out. Remember, the dendrites are the place that receive the information or the stimulation from the environment. The axon here in the center is the long piece that sends the information down to the end bulb or the synaptic end bulb here. And then the synapse is that juncture between the neuron and whatever cell is going to be at the other side getting the stimulation. For example, it could be a muscle cell, could be a gland, could be another nerve. Now, the nerve is usually at rest, but that doesn't mean it's not doing anything, right? There are gonna be ions going in and ions going out of this cell all the time. And so the resting potential just means at homeostasis. When this neuron is not firing an action potential, when it's technically resting and just hanging out being a cell, then its electrical potential is negative 70 millivolts. That means that there's a little slightly more negative charge inside the cell than there is outside the cell. So you would imagine more negatively charged ions inside the cell than outside the cell. Now, the nerve is resting, but now it needs to act. So it is receiving all this stimulation at the dendrites. I've got little circles here for excitatory stimulation and little squares here for inhibitory. So as you can see, there's lots of circles around, there's a few squares, and what happens is these dendrites are receiving information all the time. They're receiving some things that tell it not to fire and some things that tell it to fire. Once there are enough excitatory stimulation to say, yes, let's fire, let's make this nerve happen, then all that stimulation builds up here at the axon hillock. Once we have enough excitation to make this neuron fire, we say it has reached threshold. So this is an all or none response. You can't have a little action potential. You have to either do it or don't do it. So once we have reached threshold, all of that impulse reaches this axon hillock, and it's all a change in electrochemical gradient. It's all a change in how many electrolytes are going into the cell versus out of the cell to change the negativity. Okay, you don't need to know all those numbers at this level. Just know that it's becoming more positive, and so we're changing this potential across the membrane. So if you look at sodium and potassium, sodium is typically in a higher concentration extracellular. So typically sodium hangs out in higher concentrations outside the cell. Now there would be some on both sides of the cell, right? But there'll be some moving all the time, but the greater quantity is extracellular. Potassium is the opposite. Potassium is more highly concentrated intracellular. So as this stimulus reaches the axon hillock, that triggers sodium channels to open. So this channel here would open where it would normally have been closed, and sodium can now rush into the neuron. When that happens, we call this depolarization. Depolarization. The rush of positive charges is going to bring the inside of the cell to a higher positivity, closer to 0 on the millivolts. Now, this overload of positive charge in the cell causes potassium to rush out. So these potassium channels will open and potassium will rush out of the cell. And that is called repolarization because we're going to get rid of some of that positive charge and move it back farther down toward that negative resting potential. Now these actions occur in a wave-like fashion. So sodium channels open and sodium rushes in, potassium channels open, potassium rushes out. And this causes a local potential change so that the next segment of the axon will do the same thing. Sodium rushes in, potassium rushes out. And this will happen in a wave-like function all the way down the length of the axon as each local area excites the next nearby area to cause depolarization and repolarization. Once this nerve impulse goes all the way down the axon, the last area here is full of calcium channels, and calcium channels will then open and calcium will rush in. Calcium's job is to stimulate the vesicles. So these small circles are vesicles holding neurotransmitters. The calcium channels open, calcium rushes in. It acts to make the vesicles release the neurotransmitter. So you can see a vesicle here joining with the cell membrane and releasing the neurotransmitter by exocytosis. And now the neurotransmitters are floating in the synapse. And the neurotransmitters can then bind to the receptor on the next cell, the receiving cell, and that will cause whatever stimulation to make the next cell activate. So this is what's called an action potential, this whole process of receiving stimulation and depolarizing and repolarizing the axon until release of neurotransmitters into the synapse. So this hopefully will help you to understand neural impulse a little better. Thank you for watching.